All right, number 2 for the addition method or elimination. We have choices about whether we try to eliminate X or Y. Either one would work. You might notice that the Y's already have opposite signs, one negative, one positive. You might notice that 2 goes into 8, or you could go over and look at the X's. Maybe you notice that 5 goes into 15. So really, focusing on common multiples for the X's or the Y's, either one would be just fine. It's just whatever you notice first. I'm going to choose to eliminate X just to show you that it can be done, because I feel like for most of the problems, eliminating Y is usually what we do, but I don't want you to think you can't eliminate X. So I am going to choose to eliminate X. If you want to try eliminating Y and check your answer with mine, you should see it comes out to be the same in the end by the time you find both variables. So let's try to eliminate X. What I need is for these variables to cancel out. Right now, 5 plus 15 is 20. That doesn't help anything. I need them to cancel. So if I could just get that 5 to turn into negative 15, then they could cancel out. So what I'm going to do is multiply the first equation by negative 3, because negative 3 times 5 would be negative 15x. Okay, so I'm rewriting that to the left here, negative 15x. Negative 3 times negative 2 is positive 6y, and then equals negative 9. Don't forget to distribute to the other side of the equal sign. Sometimes we forget about that. The second equation, rewriting it, 15x plus 8y equals 16. Okay, now when we add the equations together, the x's cancel out. Negative 15 plus 15 adds to 0. So the x's are eliminated. We can add the y's now. 6 plus 8 is 14, so 14y. And then negative 9 plus 16 is 7. Now be careful here. It kind of looks like the answer might be 2, but it's not. It's going to be a fraction. So when we divide by 14, we get y equals 7/14, which reduces to y equals 1/2. That can happen. We do get fractions sometimes, so don't panic. It doesn't necessarily mean we did anything wrong. It's just one of those possible situations you can have. So now that we got our answer for y, now we can plug in and find our answer for x. I'm going to choose to use the first equation to plug into because those numbers look a little smaller, a little more reasonable. And we're going to plug in for y. We'll replace y with 1/2. So let's see, 5x minus 2 times 1/2 equals 3. So I just plugged in, just highlight that. I just plugged in 1/2 for y. And now we're going to work on solving for x. So 2 times 1/2 is actually just 1. So that works out nicely. So 5x minus 1 equals 3. If I add 1 to both sides, I would get 5x equals 4. Divide both sides by 5, and we get x equals 4/5. So our solution set, just write it up above here, would be 4/5, comma, 1/2. Make sure you list the x first before the y, no matter which one you happen to find first. Okay, so that's an example with fractions. I do want to remind you about checking. So we just used the first equation to plug in. So I'm going to show you how to check in the second equation. I'm going to pause and clear my screen before I check it. Okay, we just got 4/5, 1/2 for our solution. We had gotten that by using the first equation, 5x minus 2y equals 3. So it's less important that we check in that equation since we just used it to get the solution in the first place. What I'm going to do now is check it in the other equation that we haven't used most recently. And of course, if you want to be really thorough, always check it in both. It's just that it does take more time and energy. And so I'm telling you there's a slightly shorter option for you that you can still be fairly confident of. So we're checking just in the second equation. Okay, so I'm rewriting. Instead of 15x plus 8y, we're going to replace the x with 4/5 and then the y with 1/2. So 15 times 4/5 plus 8 times 1/2 equals 16. We're checking to see if this is true. Of course, you can use your calculator, but I'm going to do it without. So 15 over 1 times 4 over 5, I can multiply across. That would be 60 over 5, which is 12. So I get 12. Or you can reduce the 5 and the 15 to be 3 over 1. Multiply across, 3 times 4 is 12, over 1 times 1 is 1. Either way, you get 12. 8 times 1/2 would be 8/1 times 1/2. That's 8/2, which is 4. Or you can reduce earlier. 8 and 2 become 4 and 1. When we divide by 2, 4/1 becomes 4. So long story short, we have 12 plus 4. And yes, that does equal 16. So yes, it does check in that second equation. You can, of course, also check it in the first equation, but we were more confident that that one would work because we just used it to get our solution in the first place. Okay, so now you've seen a couple examples with elimination, and now you know we can get fractions for our solutions. That is a possibility. So it doesn't necessarily mean you got anything wrong if that happens.